Hello and welcome. Today we're going to do the 2022 VJC Prelim Paper 2, question 1. This is a question on algebraic vectors. Not dealing with any numbers here. We have a relatively simple, straightforward setup where you have points OAB being on a straight line and you have a point C such that ABC is a triangle. Okay, so like we alluded to earlier on, vector A is OA, vector B is OB, vector C is OC. No numbers here. So part 1 says, can you show the area of triangle ABC can be expressed as K, which is a constant, times modulus of B minus A cross C. Now, let's take a closer look at what we're supposed to show, this expression over here. Inside the modular sign, you see a vector, which is B minus A, cross another vector C. B minus A is OB minus OA, which is AB, right? So I'm doing AB cross C. C is OC. AB cross OC. Now, this is not the typical way that we'll find the area of a triangle. Had I not looked at this question, I would tell you that the area of triangle ABC would be half AB cross AC and not OC, which is a bit strange, but I guess we will just have to make do with what we know. I'm going to start my approach with what I said earlier on. I'm going to do half AB cross AC. Let me minimize this and get started on the question. So the area of triangle ABC is half, and I'm going to use a modular sign, AB cross AC. Why do we use a modular sign? That is because AB cross AC will result in another vector. And I don't want a vector, right? I want the area, which is a scalar quantity. So we use the modular sign to de-vectorize AB cross AC. Next, we have already known, right? AB can be written as B minus A. So I'm going to do that. And AC is just C minus A. And right now, at this step, you can see we are very, very close because this, what we just worked on in this step, looks very similar to what we're supposed to show, right? Only difference being that instead of B minus A cross C, I have B minus A cross C minus A. So what I can do is sort of like expand brackets, take B minus A as a whole vector, cross it with C, then B minus A as a whole vector, cross with negative A. Okay, this is what we get. And the next thing you notice is it would be great, because this is what we're supposed to show actually. It would be great if this went away or disappeared. And then you make an observation, which is this is AB, this is OA, right? AB cross OA. AB and OA are parallel. When you cross parallel vectors, you end up with a zero vector. So I can sort of replace a zero vector. Okay, and you probably want to write an explanation saying that because... Okay, sorry for squeezing at the side, I ran out of space. Okay, and with that we can conclude this is what we're supposed to show. Right, where K is equals to a half. Right, and that is part 1. However, although this question is done, I think what is really interesting is our original question. Because, yeah, why would it be the same crossing with AC and OC? Okay, and this is where I will want to do a bit of a deep dive. I'm going to show you this app from GeoGebra. If you're interested in it, I've included a link in the description. You can go and play around with it. Now, if you've never seen this before, it will be a bit mind-blowing. We have two different vectors, right? So if I fix U and I move V around, you can see that the cross product changes. Sometimes it points downwards, sometimes it goes upwards. Yeah, but in the context of question 1, we are not really interested in the direction because we're not interested in the vector representation of the cross product. We're actually interested in the scalarized representation, meaning I only am interested in the size of the arrow that says cross product. So I want you to pay attention to the size of the arrow cross product as I'm going to do something weird. I'm going to move V around. Again, I'm going to keep U fixed. I'm just going to move V and notice what is happening. when I move V. I'm moving V in a very specific way, right? And I want you to pay attention again to the size of the cross product arrow, right? Can you see what I'm trying to do? What is the pattern over here? Okay, I'm going to make a small little slip up, and I'm going to go back and try and do my pattern again. And you notice that as long as I move V in a direction that's parallel to you, the size of the cross product remains the same. Yeah? So why is this so? If this is the first time you're seeing, you'll be like, whoa, why should they be the same? It's a bit not intuitive. Say if I call this vector that's perpendicular to you, let's call this V1, let's call this V2, V3. Why should U cross V1, U cross V2, U cross V3 be the same? It doesn't make sense because V1, V2, V3 are not the same vectors. So let's do a bit of deep dive. Let's make this U. Okay, and then I can call this, you know, maybe this is V2. Why would U cross V1 and U cross V2 be the same? Okay, let me explain to you. I can sort of look at V1 and V2 and break it down into two components, a vertical component and a horizontal component, right? So V1 is the same as D plus E1, right? Vector addition, right? D plus E1 will get you to V1. Okay, then we also have E2. D plus E2 will give you V2. Okay, vector addition again. D plus E2 is the same as V2. And then from here, I think it's pretty clear why when you when you cross U cross V1 and U cross V2, why are they the same? Because when you do U cross V1, U cross V1, this is what we just did in the other question, right? This is U cross D plus E1. Okay, and then you can write it as U cross D plus U cross E1. And because U and E, E1 and E2 are parallel, so U cross E1 is 0. Right? U cross E1 is 0. So this thing is 0. So I can say that U cross V1 is as good as just U cross D. Yeah? So U cross V1 is the same as U cross D. And if you do a V2, U cross V2 will be U cross D and U cross E2. But U cross E2 is 0, so that's U cross D again. And that's really interesting, isn't it? What you're really doing is just crossing with the component of the vector that is perpendicular to you, right? Why is this the case? And you might look at the way cross product is defined, because we use sine, right? Sine means that, okay, sorry for drawing more lines, but if I were to drop, say, a vertical line here, and this is theta 1, what is sine theta 1? Sine theta 1 is opposites over hypotenuse, and you're actually looking at the opposite side, which is, you know, the height is, right? So when you cross these things, U cross V1, U cross V2, it is exactly the same. Okay, and that is going to help us in part 2. Part 2 is asking for a geometrical interpretation of modulus A minus B cross C. Okay, so first of all, what is A minus B? Okay, so this is as good as finding what is the magnitude of BA cross OC. Now, coming from what we know just now, right, then BA cross OC is as good as just BA cross D. So maybe you want to look at the definition of cross product degrees. That's nice because this is 1, right? We're given in the question that, you know, AB or BA is a unit vector. Sine 90 is also 1. Okay, the modulus of BA cross D is modulus of D. And what is the modulus of D? Well, you can say it is the perpendicular distance from C to AB. That is the answer for part 2. Now let's move on to part 3. Part 3 is saying that show that OB, right, length of the vector OB or the line segment OB can be expressed as this expression over here. C modulus of C dot B minus C dot A plus a constant Q. Now, this might be familiar to you. It looks like an expanded bracket. This was actually C dot B minus A. Okay, and what is C dot B minus A? That is actually OC dot B minus A is AB. Okay, and you need to remember that AB is a unit vector. That is very convenient because this, then the geometrical interpretation of OC dot AB. Okay, what does that mean? It means that if you have a sun, okay, let's draw OC first. Cast a shadow, right? Imagine OC is a bar, you know, and then if the sun shines down, what's the length of the shadow? Right? The length of the shadow is OC prime. OC prime, huh? So this portion over here, right, the one in the modular sign, is OC prime. Q is going to be this length over here. C prime B. And what is C prime B? Okay, firstly, there are some information given by the question that are not shown here, and that is C is equal distance from A and B. C is equal distance from A and B, which makes C prime sort of like the midpoint between A and B. So C prime B actually is just half of AB. And since AB is a unit vector, C prime B is just half. Okay? Okay. And then OC dot AB is just going to be C. So if you expand this out, this will be C dot B minus C dot A. That's a half. Okay, and there we have shown the required answer for part 3, where Q equals to a half. And that's it. That is question 1. I hope this was helpful, especially the insights when we did a bit of deep diving on why sometimes cross product of different vectors could end up with the same results. So I guess I'll catch you in the next video.